Good evening. So this is the day 5 of our daily physics practice program. So far we have completed 4 MCQs, right? So the more main motive of this program is we have to revise the content of physics syllabus through questions, right? So it's not only about mechanics. We'll be gently, slowly we'll be starting each and every lessons through this paper program, not paper program, actually practice program, right? So daily we'll be discussing some questions, right? So this question was a provincial question, not a past paper question. It was Northwestern Provincial Paper 2020 paper, right? And it was the 50th question, right? So what are the main steps how we can do a question? I have said it in the previous questions also, when we were doing the other questions also. I said that first we should read the question carefully. Second, we should arrange the informations they have given in an ordered manner, and last we should analyze what are the laws we can apply, what are the equations we can apply, and what are the content or the theory we can use here. All right. Okay, so as we see this, we can identify that this is some sort of a question which is related to forces. Why? Because there's a string, and if you see the answers, they have said that mg sine theta. These are one of the some familiar terms we will be coming across when we find a force related question, right? Okay, so first of all we'll read the question and then go to the workings. A uniform flexible chain of mass m is hung between two fixed supports x and y at the same horizontal level as shown. The chain makes an angle theta with the horizontal at each support. Find the tension in the chain at A or B. A simple question. They have just directly said the motive, or the what are they expecting from the question, right? So first of all, to complete this question or to just try this question, right, what we should do, if this is a question which is related to forces, we should know how to mark forces first, right? So we can see there is this is a string, right? So they have said there's a mass that is acting, right? So I'll mark the forces, right? So if there's a mass acting, there will be mass like this mg, right? Okay, so if this string, now this string has been moved downwards, can you see here? Normally if there's a string, it will be looking like this, right? You see this is a string, it will be looking like this. Then only it will be, there will be a tension creator like this, right? Can you remember last question, the day 4 question, which was I discussed yesterday? That question also, it was something like this, right? So I mark the tension like this, right? If there's a mass here, the tension would be like this, right? So similarly here also, the tension should look like this diagram, right? But there is there's downward movement by the string due to this mass, right? Due to this mass there's a downward movement and there's an angle that is created. Now can you see that if there wasn't any movement originally, if the string was in this horizontal dotted line, the tension would be looking like this, right? So I'll mark that. So actually if the tension was present, right, if actually the tension was present, tension would look like this, right? Okay. So what happens, as there is a there's an angle that is created, we can apply the law of concepts. There's no laws are called concepts, right? But we can apply the knowledge of components of forces, right? Okay. Let's see how can we apply. Now can you see T, if I there's an angle, towards the angle cos component starts acting, T cos theta, T cos theta, right? Away from the component, T sine theta starts acting, T sine theta, right? Okay, half of the question is done here, right? Now if you see, simply just think, if we take force cancelling, right? Now I'm saying sum of forces acting upward should be equal to sum of forces acting downward, when if the system is in equilibrium. Listen carefully. If a system is in equilibrium, upward forces should be equal to the downward forces, right? Okay, so what are the upward forces that can be marked? One t sine theta, another t sine theta. See, at A there's a t sine theta, B there's a sine. So totally 2 t sine theta, right? Equal to downward force. What are the downward force acting? Only this blue color, which is mg, right? We should see, vertically, yeah? So mg. right? Okay. So what they have asked in the question, let's see what have they have asked. Find the tension. Tension means they are asking the value of t, right? Not the value of the t sine theta. They're asking the value of t. If they ask the value of t, what should we do? We should take all the components except t to the other side. So t equals mg to sine theta. Simple question, right? So this is the answer. Let's see, is there an answer like that? Yeah, the second one, right? This one. Second one is the answer. Can I say mj 2 sine theta? Right? One of the simple questions. So normally students think that the last 10 would be harder. Yeah, it is a bit complex, but there are instances where they will be checking your basic level also. So this is one of the question they have asked you. They have checked your basic level of knowledge, right? If you know the knowledge of marking forces, that's easy. You have completed half of the question here, right? If you know how to mark the question, mark the forces, then you can apply this. There's a single equation, right? They have within a single step we can find the answer, right? Okay, hope that's clear. So meet you in a next question on day 6th, right? So tomorrow would be day 6, and hope you to meet on that explanation video, right? Thank you.